This is the B-21 Raider, America's newest stealth bomber, a machine designed to cross enormous distances, slip through some of the most heavily defended airspace on Earth, and arrive where older aircraft might never survive. It is large enough to carry strategic payloads across continents, yet shaped to behave more like a shadow than a conventional airplane. And that raises the obvious question: how can something this big become so hard to find? To understand that, we have to go inside one of the most secretive aircraft of the 21st century. At first glance, the B-21 almost looks simple: a smooth flying wing, no vertical tail, no dramatic angles screaming for attention. But that simplicity is deceptive. In aerospace engineering, the hardest machines often look the cleanest, because every visible feature that creates drag, heat, turbulence, or radar reflection has already been argued with, refined, and reduced. The result is an aircraft that seems quiet even while standing still, and that is part of its power. The B-21 is not trying to overpower defenses by brute force alone. It is trying to deny them a clean shot in the first place. That matters because the world the B-21 was built for is very different from the one that shaped earlier bombers. During the Cold War, range and payload were everything. Then stealth changed the equation, but over time, air defenses became smarter, faster, and far more connected. Modern battle networks do not rely on a single radar dish scanning the sky. They combine ground radars, airborne sensors, infrared search systems, digital command networks, satellite support, and long-range missiles that can threaten aircraft hundreds of miles from a target. In that environment, simply being fast is not enough. Flying high is not enough. Carrying more bombs is not enough. The aircraft has to survive the entire chain of detection, tracking, targeting, and interception. That is the problem the B-21 was created to solve. The United States already had bombers, but each came with limits. The B-52 can carry huge loads and fly global missions, but it was born in another era and depends heavily on launching weapons from safer standoff distances. The B-1 brought speed and payload, but not the kind of deep stealth needed against the most advanced defenses. The B-2 introduced a revolutionary flying wing stealth concept, yet it remained rare, expensive, and built in very small numbers. The B-21 was conceived as the next step. A bomber designed from the beginning to be stealthy, maintainable, adaptable, and numerous enough to matter at strategic scale. Even its name tells a story. Raider honors the Doolittle Raiders, whose World War II mission became a symbol of reach, surprise, and psychological impact. The 21 marks it as the first bomber of the 21st century, and in many ways, that is exactly what it is. Not just a new aircraft, but a new design philosophy. Engineers were not simply replacing an old bomber. They were trying to build a survivable node in a larger combat system, something that can carry weapons, gather information, communicate, adapt, and keep evolving as threats change. And that is where things become even more interesting, because the B-21 is secretive in a very unusual way. With many aircraft, we can recite the dimensions, the maximum speed, the exact payload, the engine model, the internal layout. With the Raider, many of the most revealing numbers remain classified. Its exact range is not public. Its full payload details are not public. Some of its mission systems are deliberately hidden. But that secrecy is not just bureaucratic caution. On a stealth aircraft, geometry is capability. The less an adversary knows about its shape, heat behavior, frequencies, apertures, and mission architecture, the harder it becomes to build a defense around them. Still, enough has been revealed to understand its scale. The B-21 is not a compact tactical jet. It is a true long-range bomber built to span oceans and operate globally. Publicly, it appears somewhat smaller and tighter than the B-2, which itself is enormous, closer in wingspan to a commercial airliner than to a typical fighter. Think less of a dart and more of a silent platform, one that trades dramatic speed for persistence, access, and survivability. To understand how it works, imagine walking from the front of the aircraft to the rear. In the forward section is the crew area, a protected command space embedded inside the smooth leading edge of the bomber. Unlike older bombers with visibly protruding canopies and distinct fuselage forms, the B-21's front end is blended into the wing, reducing features that would bounce energy back toward a radar source. The crew does not sit in a traditional nose so much as inside a carefully shaped control cell. That space is likely packed not only with flight controls, but with sensor management systems, navigation, communication links, defensive awareness tools, and mission displays designed for a dense information environment. Move farther inward, and you reach the center of the aircraft, the most important real estate in the bomber. This is where the internal payload bays are believed to sit, deep inside the structure, because stealth aircraft avoid hanging weapons externally whenever possible. External stores are aerodynamically costly, but more importantly, they are radar disasters. So, the B-21 hides its offensive capability inside closed bays, preserving the clean outer form that makes penetration possible. Around those bays are fuel volume, structural load paths, electrical systems, environmental controls, computing hardware, and the network backbone that links everything together. In a bomber like this, the center is not just where the mass is. It is where the aircraft's identity lives. Farther back are the engines, and this is one of the most fascinating parts of the design. The B-21's propulsion system is buried within the aircraft rather than mounted in exposed pods like an airliner. That choice solves one problem and creates several others. It helps shield the engine faces from radar, because spinning compressor blades are highly reflective targets. It also helps blend the exhaust and reduce the heat signature. But buried engines are harder to cool, harder to service, and harder to feed with clean airflow. Engineers have to shape the inlets so air can enter efficiently, while the engine remains hidden from direct line of sight. Then they have to manage exhaust so the aircraft is not painting itself across the sky in infrared. And that brings us to the core question: how does a bomber this large avoid detection? The answer is that it does not rely on one miracle technology. It survives by managing signatures everywhere, all the time. Radar signature, infrared signature, electronic signature, acoustic signature, even maintenance signature. Stealth is not invisibility. It is disciplined reduction. Start with shape. Radar works by sending energy outward and listening for reflections. If a surface is perpendicular to the radar, a strong return often comes back. If that surface is angled, blended, curved in specific ways, or arranged so the energy is redirected away from the emitter, the return can be dramatically reduced. The B-21's flying wing planform is ideal for that logic. It eliminates many of the vertical and protruding surfaces that make conventional aircraft easier to detect. Its edges, inlets, doors, seams, and transitions are all part of the stealth equation. Even small features matter: a gap, a hinge line, A panel mismatch or an exposed sensor can become a bright point on a hostile display. But that is only part of the story. Shape helps manage reflections, yet radar is not the only threat. A stealth bomber must also control heat. Jet engines produce enormous thermal energy, and modern sensors do not need a radar return to notice something warm moving against a cold sky. So, the aircraft has to bury engines, mix exhaust, shield hot components, and spread thermal loads in ways that make the aircraft less distinct. The goal is not to become cold. That is impossible. The goal is to become confusing enough, faint enough, and late enough that a weapon-quality track arrives too slowly to matter. Then there is the electronic problem. In older warfare, simply detecting the target was hard. In modern warfare, emitting from the target can be just as dangerous. Every radio, radar, data link, and transmission is potentially a beacon. So, the B-21 is not just shaped for stealth. It is designed to operate intelligently inside a larger network, using advanced communications and mission systems while carefully controlling what it reveals. That is one reason open systems architecture matters so much. It allows the aircraft to evolve its electronics, sensors, and software without redesigning the whole bomber every time threats change. At first, open architecture sounds like a software term, not a stealth breakthrough, but it may be one of the Raider's most important advantages. Older military aircraft often become technological museums over time, trapped by proprietary hardware, aging computers, and upgrade paths that are slow and expensive. The B-21 was built with growth in mind. That means its sensors, processors, communications packages, and mission tools can be updated more rapidly as new radars emerge, new electronic warfare demands appear, or new weapons are integrated. In other words, the aircraft is not frozen in the year it was designed. It is meant to keep learning. However, the real secret may lie even deeper than that. The B-21 is one of the clearest examples of digital engineering becoming a combat capability. Before the aircraft flew, engineers were already iterating through massive numbers of designs in digital environments, testing shapes, systems, performance, production methods, and sustainment logic long before final hardware existed. That matters because stealth bombers are not just difficult to design. They are notoriously difficult to build consistently. One imperfect panel fit, one maintenance burden multiplied across a fleet, one hidden systems conflict, and costs can explode. Digital engineering gives designers a way to find problems earlier, reduce surprises, and align manufacturing with the original aerodynamic and stealth intent. That is why the B-21 is so significant. It is not just a stealth bomber. It is a stealth bomber built to be produced and sustained more intelligently. For decades, one of the biggest challenges in advanced aviation has been turning exquisite prototypes into reliable fleets. A handful of astonishing aircraft can impress the world. 100 operational aircraft can change strategy, and strategy is exactly where the B-21 lives. In real-world terms, this aircraft gives the United States a way to hold distant targets at risk with either conventional or nuclear weapons, from land bases with global reach. It can support deterrence without being visible on every radar screen the moment it departs. It can carry standoff weapons when staying farther away makes sense, and it can support direct attack roles when access is the real challenge. It is also expected to operate as part of a broader family of systems, contributing not just to strike missions but to sensing, communications, and flexible long-range operations in highly contested environments. Of course, no aircraft is magic. Stealth reduces detection. It does not eliminate it. The B-21 will still depend on planning, support, logistics, and tactics. It will still face evolving counter-stealth technologies. It will still be expensive, complex, and politically significant. And because so much of its capability is classified, some of its true strengths may remain unknown for years. But, in a way, that uncertainty is part of the deterrent. An aircraft becomes more formidable when its adversaries cannot be sure what it can see, what it can carry, how far it can reach, or how late they will notice it. That is why nations invest billions in machines like this. Not because they are dramatic symbols alone, but because they reshape the geometry of decision-making. They force planners to think differently. They stretch defensive systems. They complicate assumptions. They preserve options at very long range. And in the world of strategic aviation, preserving options is often the difference between relevance and vulnerability. The B-21 Raider matters because it represents a shift in what a bomber is supposed to be. Not just a truck for weapons, not just a stealth shape in the sky, but a survivable, upgradable, digitally engineered platform designed for an era when information, signatures, networking, and adaptation matter as much as thrust and payload. It carries forward the logic of the flying wing, the lessons of stealth, and the demands of modern combat into a new generation. And maybe that is the most remarkable thing about it. The B-21 is impressive not because it looks futuristic, but because it turns restraint into power. Fewer obvious surfaces, fewer emissions, fewer chances to be seen. Behind that calm shape is an extraordinary amount of engineering, all devoted to one purpose: reaching places that are designed to be unreachable. For more deep explorations into the world's most fascinating machines, aerospace technologies, military innovations, and scientific breakthroughs, subscribe and join us for the next one.